Hello, and thank you very much for joining me at my poster, Characterization and Sample Collection of Aerosolized Liposomes Applying Gas Phase Electrophoresis on a nES, GEMMA, or nES DMA instrumentation. My name is Weiss from TU Wien, and I will guide you through my poster. The aim of my poster is to demonstrate that liposome characterization is possible via gas phase electrophoresis. You will gather information concerning vesicle purity, vesicle size, and sample heterogeneity. In addition, it's possible to offline hyphenate gas phase electrophoresis with other analytical techniques, for instance, atomic force microscopy, spectroscopic, or mass spectrometric techniques. In the first part of my poster, you will find an introduction to the nES GEMMA instrumentation. The instrument itself consists of three parts. In the first part of the instrument, analytes are transferred from a volatile electrolyte solution to the gas phase. There, the electrolyte evaporates and charge equilibration occurs. Next, the polydisperse aerosol is introduced to the second part of the instrument, the nano-differential mobility analyzer. There, particles are separated in a high laminar sheath flow and an orthogonal tunable electric field. By variation of the field strength, analytes are size separated and finally are counted in the condensation particle counter unit of the instrument. In the end, we'll get a spectrum where, and you can see it here for liposomes, where particle size is related to particle count values. And as you can see here, for liposomes, it's possible to get spectra of differently concentrated vesicle samples, indicating that we're indeed detecting liposomes and no unspecific aggregates. Besides counting particles yielding spectra, it's also possible to size select particles after the nano-differential mobility analyzer step. When doing so, it's possible to collect bio-nanoparticles, liposomes in that case, on corresponding substrate materials. To do, for instance, atomic force microscopy of those vesicles, you can see it here in the left column, or you can also do spectroscopic analysis, as you can see here in the middle column, for instance, targeting not only lipids forming the liposome, the lipid bilayer of those vesicles, but it's also possible to target cargo molecules which are sitting inside those transporter molecules. Last but not least, it's also possible to target lipid species forming the lipid bilayer, for instance, via mass spectrometry. And this you can see here on the right-hand side. This is not only possible for samples just containing liposomes, but it's also possible to size select bio-nanoparticles, liposomes in that case, out of complex mixtures or out of complex media. So to sum up, it is possible via gas phase electrophoresis to characterize liposomes in depth. We'll gather information concerning vesicle numbers, vesicle purity, and analyte heterogeneity. And it's also possible to offline hyphenate gas phase electrophoresis with other analytical techniques. Multi-mass spectrometry, atomic force microscopy, spectroscopic techniques, and many others. Cargo molecules can be targeted, and it's also possible to size select liposomes out of complex media and out of complex samples. In case you have any questions, please feel free to contact me, and I also attached my poster as a JPEG file to my booth. Thank you very much for your attention.